Hi everyone, today I thought I'd show you the new features I've added to my Hydro controller. I've listened to all your feedback and advice, and I've put in some new sensors and redesigned the graphical interface, generally made the code more efficient, loads of different features. I'll start going through them all. First of all, you can see I've added the TDS meter, which was a common request. That's been added whilst keeping the old sensors, not to limit functionality. We've got the waterproof ultrasonic sensor compared to just the old school standard ultrasonic sensor. That's probably a bit vague. We've obviously got our transistor circuit here, same as before, but just with the addition of 2 extra transistors to power the TDS sensor as well. I will be moving away from transistors. Not that it's a bad design. I've had some electronic experts have a goose at my wiring diagram for them, and they said that it's fine. The only problem is that you're going to get a 0.3 voltage drop across there, and the ground line is going to be a bit higher than the main ground, but you know, it's good enough. I will maybe start looking at some FinFETs instead or something like that, BiFETs. Either way, transistors for now. We've got the Nano here. Prior to the Nano being added to this device, the LED and the speaker was ran directly from the Mega, and that took up quite a lot of CPU time to generate the noises. And the LED, we've used up practically all the timers on the Mega, so I couldn't use tone. So it was a case of using digital high and low with a delay in between. So again, that's taken up a lot of CPU time. So that's now been moved onto the Nano and connected via hardware serial 1. Nice and simple. We've obviously got the MOSFETs as from the previous design to run 4 doses. We've got another feature that was asked for. I've got some 4151 MPC, which is a digital potentiometer. This is the 10K version, as in it goes up to 10K, and they are going to be used. I've just got to put 2 more wires in, those 2 upper middle pins. They just need to be jumped down to these potentiometers. Here and here are going to be removed. So this is the potentiometer to calibrate the pH, this is the potentiometer to calibrate the EC. They will be cut off and wires soldered to jump to these chips, so that you can calibrate the sensors from within the GUI. The TDS sensor already has a calibration formula that you can run from the software, so obviously it does require you to put it in some calibration solution, but then again so does the EC sensor. So yeah, there's calibration support within the GUI to calibrate all the sensors, obviously not the temperature or the height sensor, because they should be accurate no matter what, within reason, obviously within the tolerance. We've also got the RTC timer here. We've got the Adafruit display. As I've mentioned in my previous video, you do not need to use the Adafruit display. You can use one of the cheaper ones, which will cost you what, £30 for the display driver and a display built into one with onboard SD card and onboard flash chip external from the main flash chip for the display, and it's got a font chip in there, and it's just a nicer package, and it costs less than it would cost to just buy the Adafruit display driver. I have my one arriving from Best Display, I think it's called. My one's will be arriving in a couple of days. It takes like a month to arrive from China, but we used them in our old company. I just had this in my drawer for many years, so I've always been using this for my prototypes. As I say, we've got the RTC clock here, DS3132 I think it's called. It's just a generic RTC shield for Arduino. Obviously not just for an Arduino, but it's a nice accurate chip. One that I'd recommend using, should I say, for an Arduino. We've got our 4 relays. Ignore these 4. I've just again had one of these in my drawer. It was an 8-channel one. We're only using 4 of them. And we've got our inlet pump, our outlet pump. We've got our temperature element, as in our heating element, and we've got our external lighting. The inlet pump's obviously used to refill the tank and add water to decrease the EC, and the outlet pump, same scenario. If the tank you can set in the GUI to set auto drain, so it'll drain the tank every X days. Or actually it's on a set date, I'll show you that in a minute. But yep, we've got inlet and outlet pump to add new water and drain water and refill the tank whenever you want. Blah blah blah. So yep, I think I've gone over the electronics. Yep, told you about the digital calibration, adding the Nano. Just get an overall look at it. It's obviously not that big. It's yeah, it's a nice tidy little design using all proto wires. So it's all flat. I don't know if you can tell from above the other camera design, but it is generally all quite neat. Everything's nice and flat. I need to lay that down, just unsolder the pins and put them for some standard ones. Anywho, it is turned on, it's in sleep mode because I haven't touched the display for a while. So, oh, it's a bit dusty, isn't it? I scratched the display cleaning it. Anyway, let's wake it up. So, as you can see straight away, we've got a new front page. And as you can see, it's an intuitive slideshow. Just like as you'd use on a website or on your mobile phone. And as you can see, it's showing the current sensor reading, the target, so we're aiming for it between 6 and 6.5. Here we're aiming for between 1.4 and 1.65 with an offset of 0.25. Obviously it shows the time in the top corner as well. I was going to show the whole date and time, but it just cluttered the display, so I just stuck with just the time. I think that's good enough. And of course we've got the graph, which is nicely scaled, as in it's the same graph used throughout the entire system, but I've finally adjusted the code. I say finally, you probably wasn't aware, but I'd originally designed the graph to be scalable, but I had a little error now, just never got around to fixing it. So I've fixed it all now so that the graph, you can scale it to any size and it will map it all. You know, all those numbers are worked out automatically. It works out the maximum number to have on the y-axis and the amount of sensor readings to have on the x-axis, and it wouldn't show any more on the x-axis than it needed to, blah blah blah. Obviously as a slideshow, you can, oh, I forget that the display has to finish showing before the touch event will start again. But yeah, we can, standard scrolling. That's obviously again all coded by me. I don't know of any other examples of people doing that. I always write the code myself. This is more about just playing with code than trying to make a device. So yeah, for those who haven't seen this device before, again we've got our graph. The old system did have a bug where it wasn't actually showing the fourth graph option. In this case obviously we have 5. We have TDS, which I might actually rename to PPM, and then we have pH, EC, water temperature and water level. So obviously these are buttons, you can touch it and go over to the different modes. These are just static numbers for now. This is just obviously me testing all the stuff. I've got a a testing sketch in there, so I can run through loads of different ranges of numbers to make sure stuff doesn't overflow, and when it's been converted to Fahrenheit or inches and such, everything still centers properly, because this is text and all elements are always centered, which does make things harder. No centers obviously connected at the moment, so the maximum is going to obviously mode. We haven't got anything in there. This doesn't have, I did add it. I can't remember doing that. As in where you can roll over from the 5th back to the first element. Obviously this doesn't got a timer in it, only the home page has the timer for the slideshow. Obviously got the keyboard. Everything in here has been rewritten from scratch. I should say that nothing was copied from the old one. I rewrote everything, not even examining the old ones, just because I wanted to make it far more efficient with what I've learned over the years. The code is far more efficient, as I just said. It's really hard to try and look through the camera and work out where your finger is in space, which is what I'm trying to do now. It's press the 2 and then the 3. Are we on 10 shards? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, we're on 10. So I can just delete a couple, whatever. I'll just delete them all. Oh, press the wrong one. I'll just write my name in there. which is Edwin. We'll go for uppercase, do it all properly. E, lowercase, D, W, I, N, and enter. And of course, that is actually to name your profiles. So in that case, you may name it veg cycle or veg, and that will be named flowering. That one may be named whatever. I don't know. But I've allowed to have 5 profiles where everything is saved except for the profile names. Sorry, I said that wrong. Everything is saved on the system to a individual profile. So you have 5 profiles, so everything you configure on here will be saved to an individual EEPROM block, with the exception of the profile names that are stored individually. Obviously you don't want to save those 5 times to 5 different profiles. That would just be silly. So yeah, you can save and load your profiles. Saving only happens when you click save, so if you adjust the value, it's not just going to save automatically, because you just don't want to kill the EEPROM. And yep, some other cool little features. Added things to even change the background colour. I haven't really worked out any colours. I'm actually going to make it so it's 2 colour themes. So for instance, this would be a little triangle going sideways, so that'd be white and black colour theme, like a mono display. For now, let's just, I don't have to use my tweezers, I can just use my finger, making it look bad by implying that you have to use your tweezers. Obviously, set your background colour to whatever you want. I prefer mine generally blue, so let's just leave it at that. Obviously you can set your temperature in Fahrenheit, your water in inches, display timeout, obviously got it set to 1 minute at the moment. You can turn that off if you wanted to, no, I would never recommend it. The graph interval, how often the new data is added to the graph. The environment, so dosing interval, by default is set to every 6 hours. Override interval, 3 tries, so if the system works by working out which one is most out of range. So if the pH is out of range by 80% and the EC is out of range by 20%, and the system had been dosing the pH for 3 tries, and the EC hadn't been touched but it was obviously out of range, it would then swap to then just adjust the EC. So this is basically to stop it from always focusing on one of the modes, because you don't want it to always be adjusting EC if you've set it to adjust EC and pH. You want it to do both, but there has to be a compromise. So it tries to do the one that's most out of range, and every X override intervals it would then swap to the other sensor, try and adjust that one, and then go back to the one most out of range. Obviously we can disable all the different modes. We can disable PPM, EC, pH. We can disable the water level control. I didn't really want to put water level in there because it was too long, so disable level control. Maybe I should change that to disable height control. Yeah, that's probably better. Disable temp control, that's obviously the temperature. Obviously these are so that's just me looking at the wrong place. I'm trying to use my finger now and it's probably not the best thing. I should just use my finger, but then you can't see what I'm doing. Obviously it's just a standard little toggle button. Let's go into the next page. Don't want to make this a really long video. Disable autofill, so if the tank gets really low, well, to the amount that you've set in the water page that I'll show in a minute, let's say you've set it to no lower than 10 centimeters. If it gets below 10 centimeters or to that amount, it will then refill the tank and it will add a set amount of nutrients. We'll have a look at the autofill settings in a second. You can disable auto drain. So on auto drain, every date that you have set, it would drain the tank and refill it. Just standard hydro practice. Disable machine learning. Machine learning, it's if your EC is at say 1.2 and the system adds some nutrients, so it's the EC is at 1.2 and it adds some nutrients, and that then adjusted the EC to 1.6, that would have been an adjustment of 0.4. So it would have saved that adjustment of 0.4 to the 1.2 EC memory block. so that if the EC is ever 1.2 in the future, it would know how much that is going to be affected by. It's a bit more complex than that, and it's to a precision of 0.1. So if you have an EC of 0 to 6, and it's actually in 0.01s, that means you potentially have 600 different blocks for your EC. So it'll look at those different blocks, try and find a value for its current reading, and determine how much to adjust the dosing amount by. And if it can't find a value, it will start searching the closest box next to the current reading. I'm going to rewrite that. I haven't actually got onto that exact part of the code yet, but that used to be in the old version, but I think it could probably be improved. Pardon me. I've spent 3 weeks writing all this graphical code, and as of literally this weekend, I'm going to start writing the algorithm control there, PPM, PH, EC, and then once that algorithm is written, I'll write the machine learning to improve or to make it learn over time how to improve the dosing amounts. You can change dose of 3 and 4 to either EC or PH mode. So if the PH is out of range, it would then obviously use the pumps that are set to PH mode to do whatever. So let's have a look at the autofill settings. This is a slider page, so this is the amount of nutrients that you want it to add into the system when it's refilled the tank. So this may be like 100 milliliters, 100 milliliters, 20 milliliters, 10 milliliters, and that'd be your A and B, your riser, whatever, and your whatever else, your pH down. So once it's refilled the tank, it would add that, a static amount, and then it would work its way from there. I need to work on that as a bug at the moment. It hasn't got, once you slide the page, wherever your finger finishes, it immediately thinks it's a button press, so I just need to put a timer in there to disable button presses once you slide the page for half a second. But this is what I was explaining earlier on. So on certain dates of the month, it can refill the tank. Obviously these are buttons. Oh, again I'm trying to let me just look normally instead of looking through my phone. So fill on certain dates, and you set the time that you want it to fill. It's the same date every day, so you start at 12, that should be 12 noon, but I decided not to have noon as well, so that's 12 noon, it'll fill on these dates. Again, obviously this is all adjustable. Just stop looking through my phone. Let's just say that it's set to whatever, 2 PM. Obviously you can enable or disable these fill on dates, and we've just got our exit button in there. So drain timeout, that's quite an important feature. So when it's draining the tank, it works with the ultrasonic sensor, but in some cases I found that the pump nozzle wasn't obviously at the very bottom of the tank, so it would never actually be able to fully drain the tank, and you don't want it to sit there forever trying to run the pump. So if the water level is the same as the previous water level after X amount of time, it would then bail the draining and assume that it's drained as much as it can. Obviously these can be adjusted. Oh, it's so weird to work out the height of something when you're not actually looking at it. My calibration's a bit out, as you can see. That's probably why I was having trouble earlier on. The new display I'm buying for £35 has an auto calibration chip, so none of this silly having to run the sketch to work out the values. Naturally, I must have, I forget, I need to resync that. This is just something I've just remembered. So obviously you can disable the LED and stuff, but the touch hasn't been working because the Nano actually saves its state, and I was meant to remove that because the master is saving the state, so I will ignore that. So now that the touch is on, I can't remember, no, so this is touch disabled, so it was obviously in reverse. Again, it started in the state reverse, so I had to swap back for us. So yeah, the Nano's constantly saving its state, and I need to tell it not to do that, which should be super simple, just delete that line of code. Yeah, so I've got the touch back, obviously you can disable the LED. Let's go back over here. LED off, LED on, and obviously that's going through the Nano. We can clear the Wi-Fi details, clear the graph history, clear max mins, factory reset. Obviously we know what the factory reset is, it's just going to delete all the settings, bring back to normal. You can disable all the different warnings, and as I said earlier on, you can calibrate your stuff. The calibrate height is not actually calibrating the sensor, it's once you've drained, you have to drain the whole tank. So this is like when you've got a new system or you want to recalibrate the sensor. The height there is, sorry, not the sensor, the height. Once the tank is completely empty, you'd press this button and it then works out the total height of your tank. Then, when you've refilled your tank, it obviously then deducts the height that it is at the top. So if your tank's 100 meters deep, 100 centimeters deep, and you fill it right up, the sensor would then read that it's 10 centimeters between where it is to the water level, deducts that from the empty height, the zero height. So you've got a zero height of 100, your tank depth, minus the current height being 10 centimeters, means that you've got 90 centimeters of water in there. I might add a little function in there, or a little extra line for you to enter in the width and length of your tank, so then it can obviously calculate the volume. And then we've got obviously your other stuff. So this is for the PPM. You enter your solution value, and this is the current sense reading. Then you'd click continue. Obviously I don't want to do that. Same for the EC essentially, but because these are working with digital pots, you'd set the ohms. That's maybe a bit advanced for some users, but it's just the way it's going to be. Now to quickly go on this, we've obviously got set your min and max target and the tolerance, the amount that you're allowing the sensor to wobble by. It will never stay perfectly stable. Your max and min for your pH. Oh, skip one. Obviously got your EC, temperature, water level, your doses. As I said earlier on, your doser mode. Oh, that's not. Forgot to add the piece of code to center that. Alright, I'll do that. That'll be my next note. Center that on press. Obviously, you could prime the pumps. Got no pump plugged in now, but set your milliliters. So this is how much it's going to start with its default dosing amount. So if the pH is too low, obviously this is pH plus. So if the pH is too low, it'll add 2 milliliters of pH up, and then wait the 6 hours before trying again, because it does take a long time for the new solution to mix in. You'd be a fool if you tried doing it even every hour. You'd be silly, and that's just for a 50-litre tank. So obviously these can be in EC mode or pH mode. Their other mode is fixed. This is pH down, pH up. Obviously set your amount. As I said, you can prime them. Got your light here, so your light on time, your light off time, whatever time you want it to come on. Your light mode on, auto, off, standard stuff. Wi-Fi, on or off. Reconnect, if it's crashed. How often you want to send your data to your server. And your error. So this is the error margin, so plus minus 50. So I have it currently set to no higher than 600, and we're currently at 628, so that'd be a minor warning. If it went to 650, that'd be an actual major warning, and it would start beeping all the time. Naturally, slideshow again, EC, pH, PPM as I said, temperature, height, and that's it, back to the homepage. So, that's the new version. As I said, I've just finished the graphical interface. I've got the functions in there to control the water height and the water temperature and the lighting. They're all easy to write. But the actual algorithm to control the PPM, pH and EC is going to be probably a whole month's work. Currently speaking to some experts from literally around the world. Just trying to get some background information on the best ways to try and predict the amount of nutrients or solution that should be added, or the amount of water that should be added or drained, based on the information that we know, which is the water temperature, the water volume, the current PPM, the current pH, and the current EC. So it's going to be a bit of a chaos theory with so many readings, and they're all going to affect each other. You can't just try and adjust the, for instance, you can't try and adjust the EC and expect the pH to remain the same or the PPM to remain the same. Obviously you could go into the interface and disable one of the modes so that you're just focusing on, for instance, the EC, but for those that want to try and control the parts per million, the pH and the EC, that's going to be a fun piece of code for me to write. Naturally there's going to be priority modes, so whatever the one is most out of range is what I'll try and do first, but it has to be more than that. It can't just turn a doser and add 2 milliliters that the user specified and then wait loads of time and expect that to be correct. It's going to have the machine learning so that it learns how much a set amount of nutrients within a given range would affect the readings. Yeah, so essentially it's going to take loads longer to write the core algorithm to control the main 3 sensors than it is to write the whole interface and all the wiring and the networking, which is not surprising really, but I really hope you like the new interface, and I plan to have this version released before Christmas of this year, but you won't be seeing it for at least another month. And as I did mention, the old version does have a few bugs in it, nothing major, but it's nothing compared to this one. This code is so much more efficient. I generally wouldn't mind any coding developer having a look at my code for this one. It is all very cushy, and I've had the wiring reviewed. It seems adequate was the exact word. Obviously it could be improved a bit. Yeah, so I'll keep you updated in the next month to 6 weeks, or should I say 4 to 6 weeks, with the new software. The wiring has somewhat changed obviously, but I've kept every other pin the same, so if you've currently built the old version, you won't have to do much work to get the new version working. A TDS sensor, an Arduino Nano, and 2 digital potentiometers, and you're golden. And yeah, you'll have the whole thing working. So I'll keep you updated, and cheers for watching my video. See you later.